Hello everyone. This video is going to be on how to set up and use your MFO-1 oscilloscope generator module by GSD Electronics. By now, a few of you have probably already played with this, probably know what you're doing, but for those of you who haven't yet, let's go over it. This is a USB controlled unit, so you'll have to plug in a USB cable. You'll need software, and you should be able to find that by going to a link that I've already sent you by now. Everyone should have it. So just click on that link and your browser should open to the GDS or GSD page for the product details, and you can go through that if you like, see what this thing is capable of. If you want a detailed manual on how to use it all. Also, most importantly, where to get your software to run this thing. Just download the flavor you like the most. So we've got it plugged in. I'm also going to plug in a cable to the output for the generator output. I'm going to put one of the scope probes on input A and the other scope probe on input B, and they're wired up to this little circuit here, which is effectively this little circuit here, just an RC circuit. What we're going to do is run the program, and it comes up with 3 panels. The waveform generator panel, which allows you to control the waveform generator. The digital I/O panel, which lets you take care of the digital input and outputs. Basically, you just look at these. If there's a 5 volts on the pin, these will be lit. If there's 0 volts on the pin, they'll be off like this. Same with the outputs. Turn them on, they're lit. Turn them off, they'll be 0 volts. So you get 5 volts or 0 volts on the I/O pin. And you can also generate PWM signals with a given duty cycle and a given frequency on whichever I/O pins you have set up. We're not going to do anything with the digital I/O, so I'm just going to get rid of that. Waveform generator, you can select your amplitude, your frequency. I'm just going to set that at 50 hertz. You can put an offset voltage into your signal between 3 and -3 volts. And you can set the amplitude from 0 to 100%. Now let's look at the oscilloscope panel. It's similar to your bench oscilloscope. You've got your vertical channels, A and B. You can set the sensitivity by clicking on the plus and the minus sign. It's got a horizontal time-based section, which allows you to control your sampling frequency. So basically this is set up for 2 milliseconds per division. And again, click on the buttons to change it. Also, there's the trigger control. Right now it's set to trigger on channel A, and if we look at the options, we can have source A or B and slope rising or falling, and as you can see, it's set for A with a rising edge. You can also change the trigger mode from auto to normal to single shot and external trigger. We can separate the signals just by grabbing onto them and moving them up and down. So there's channel A, channel B. You can adjust your trigger level just by grabbing onto that little T and moving it up and down. So we'll set that to about 50%. Now as you can see, the trigger level's there. Now you notice without the trigger level being in with the signal just dances around. Not that useful. So if you want a nice triggered signal, just drag it down in, and there we go. So now you can see I can make the waveform quite stable by having the trigger level set in the middle. Now you can have that triggering on B or just leave it on A, whatever you want to do. Now this shows just the basic waveform. I can expand it out. I can shrink it down so I can see more cycles of the waveform. This is at 50 hertz. And if you go back, remember what we have here. We have a resistor and a capacitor. So as frequency goes up, this capacitor impedance is going to go down. So effectively, more of the signal will get dropped across the resistor. So we'll see less here at the output. So let's look at that. Right now, they're pretty much equal at 50 hertz. So if we put that at, say, 500 hertz and change the, as you can see, now the sampling or the signal level of B is starting to fall. Take it higher, say 1 kilohertz, even more so. Now, if you want to do a full frequency response of this circuit, you can go through this step by step, take one point at a time, make measurements, and throw the information into an Excel spreadsheet and graph it to get a plot of the frequency, and you can measure the phase angles and everything else as you go. And if you don't want to read the measurements off the screen, just bring up the auto measurements panel, and that gives you a live reading of all the values: frequency, period, average voltage, maximum, minimum, so your peak values, your peak to peak value, and it can calculate RMS. So if you want those readings, you can get them that way rather than try to read them off the number, count the number of divisions and multiply that by the volts per division. Same thing with the time base. Now, this unit will also act as a VNA, giving you the ability to measure a whole bunch of points and plot the results. So basically, it will sweep through the frequency and plot the amplitude versus frequency, as well as the phase angle versus frequency, and give you a both plot. So we turn that on. We can choose, so we're going to start at 10 hertz, go to, let's make that 10 kilohertz. I don't think we need to go any higher than that. And I'll leave the frequency step alone. And we'll change the waveform amplitude maximum to 50% or so, and press start. Give it a few minutes to collect the data, so you can see the points changing. So you can see it stepping through the frequencies, and you can see the values. So the amplitude's pretty flat over these frequencies, and just let it keep going. And as you can see, now the amplitude's starting to fall, the angle's starting to shift as it goes higher and higher. And it gives you a nice bode plot showing the frequency response and phase response of your circuit. There. Done. And as you can see, as I move my cursor around the graph, I can see where I am, so what the amplitude is and what the frequency is at that point, as well as you can see what the phase angle is at any point on the graph that you want to look. So that's kind of useful as well. So let's go back to the oscilloscope mode. Now, one other thing you can do with this, and you'll probably use this in one of your courses, is to bring up spectrum analysis. So basically, this is an FFT capability. So it'll show your frequency content, and you can, as I change the frequency, you can watch this. There we go. You can watch the peak move across. Let me change that to a square wave. There. So a square wave, get a good sampling on the frequency here. and have a look, you can see the different peaks that make up the square wave. So that's kind of cool. Well, that's basically it in a nutshell, guys. I hope you get good use out of this, and we'll see you once again. Bye-bye.